As a geologist, there are some things that we can do in the lab that we can't get done in the field. So over the summer, we visited over 60 sites, collected about 5 large tubs worth of rocks, and brought them back to the lab. Here we can do some techniques to get information out of the rocks that we cannot get in the field. Coring for magnetic work involves drilling 1-inch diameter cores into the rock and then cutting them into smaller specimens that I then run through the magnetic susceptibility bridge to analyze the magnetic signature of the rocks. After I've drilled the cores in my rock, I need to reorient them in space as they were in the field using the rock in the sandbox and my compass as a level. I can use the measurements I took in the field to put the rock back in physical space like it was in Idaho. Reorienting involves finding the horizontal plane lines reference and also finding north from the arrows that I drew. After the rock is aligned, I need to find the orientation of the cores that I've drilled. So I can use my compass again to find their orientation in space, so that when I make magnetic measurements, the geometry is referenced back to physical space in Idaho where the rock was in the outcrop. I analyze the smaller specimens of the cores that I've drilled using magnetic techniques to determine the geometric alignment of the iron-rich minerals within the rock. Back in the lab, we make thin sections of the rocks, which involve slicing the rock into very thin slices about the thickness of a human hair. We can look through the thin sections with a microscope to determine which minerals are in them and the structures and the patterns within those minerals. Looking at the boundaries between the different minerals can tell you something about the conditions at which the minerals formed and that the rock formed under, like the pressure and the temperature beneath the earth. The grain boundaries also tell you something about the interaction between different minerals as they're growing in a magma. Different elements are being exchanged between those minerals, and that's how you end up with different minerals. Both the thin sections and the magnetic work tell us more about the three-dimensional geometry of the minerals within the rock from the specific field site that the rock was collected. The data that I collected in the field and in the lab will be used in combination with the geophysical work that our collaborators are doing to work on interpretations of the tectonic setting and the magmatism and the deformation that happened in Idaho beginning about 90 million years ago.